Okay, this Mr. Boomhauer, we're going to look at an extended challenge based on the Hexagon Train Task that we worked on during class last week. Using proportional reasoning with correction is a method that you can do to get the perimeter of any given number of hexagons. Let's start with the number of hexagons that we know the perimeter for already because we calculated it, or we can count it. 5 hexagons. 5 hexagons, you can count around the perimeter, 1, 2, 3, 4, 5, up to 22. So for 5 hexagons, a perimeter of 22. What about for 25 hexagons? Okay, now 25 is getting to be a number too high for me to count. I don't want to count the perimeter of 25 hexagons joined together. So I'm going to use this method. I'm going to say, because I know that 5 hexagons together gives me a 22 perimeter, I'm going to estimate and say that 25 hexagons should be 5 times 5 is 25. So 22 times 5 is 110. So I'm going to say 25 hexagons. That means I should expect 110 approximately for my perimeter. Now I know that's not exact. I know that now I have to make a correction. I have to go back. I need to account for those shared sides that we found when we investigated this during class. For every string of 5 hexagons, I'm joining up a new string of 5 hexagons. So we're going to share a side. So 2 sides are going to come together and no longer contribute to the perimeter of the train. So every 5 hexagons, I need to subtract 2. So I'll come through, as you can see in the image here, after every 5 hexagons, there's a blue line that represents a shared side that needs to be subtracted. A shared side, one from each train. So minus 2 for that first blue line. Minus 2, minus 2, minus 2 for all 4. So 8 sides needs to be subtracted from 110, leaving me a total of 102 for that perimeter. Okay, now let me provide you with the challenge that I want you to work on for your extended challenge homework here. I know you're thinking, why do I need this proportional reasoning? Because I already came up with an equation during class. The equation is the most efficient way to get to a solution here. But part of the challenge for this activity and for this math class in general for the whole year is to get you to look at things in a variety of ways, to be able to come up with multiple representations and multiple points of view on any given solution or any given task. So the challenge here is to look at this proportionally. So that's a justification. Here you go though. Here's your challenge. Take 4 hexagons as your benchmark this time, or as your starting point. We know that the perimeter for 4 hexagons is 18. Use proportional reasoning with correction, show a diagram, and find the perimeter for 224 hexagons. Include all your work. Come to class with this material and show it to me, and we can have a little discussion and see how it went for you. Okay? Good luck. You can also feel free to go as far as you want with this, by the way. You can try different number of hexagons as your benchmark or your starting point. You can even try this with different kinds of polygons. Those are also a few other extensions you can add on to here to keep yourself challenged. Okay, see you next week.